Alright, so we are in the 15-1 notes, continuing from last week, so pick it back up. Who can remember, or does anyone remember, that little story that I told, which supposedly is a true story, but take it for what it's worth. Michelle, what was the little story that I told about Einstein?
Einstein was a troublemaker, so his teacher was like, do this, and you're not allowed to do anything else until you're done with this.
Now, what is do this? What was the this?
This thing was the thing where the teacher said add the numbers 1 through 100.
Now, depending on how evil you want to make the teacher in the story, it can be 1 through 100, 1 through 1,000, 1 through 10,000, 1 through 1,000,000, depending on how evil you would like that teacher to be.
Let's go through that.
Now, Einstein, so where's the story go?
Einstein comes back 2 minutes later, I'm done, and then the teacher is like, how did you do that?
Yeah, so on top of Einstein already having frustrated his teacher to the point that they gave him this side assignment, he then finishes this thing that they thought would keep him busy for a long time in no time flat. Has anyone heard this story before? You ever heard this riddle presented as a math sort of thing? Yeah, you have a question?
Yeah. So if the teacher didn't know how to do it, how did she know that he didn't just write down some random answer?
I mean, there are mathematical techniques to have it done, and we'll talk about summation and things like that.
Do you think she knew the actual answer?
It doesn't even matter. The point was to eat up time.
I'm just saying.
Well, all the teacher was trying to do is make Einstein go away. Go over here and be busy for a while.
That's what his pedigree told me.
If a kid came up to me and was if I was a teacher, I'd be like, you didn't actually do it in 2 minutes. You just wrote some random number. Go back.
So,
working.
I love it. So then, what if the teacher said, no, there's no way you did that. There's absolutely, you're lying. And he said, no, right here, I did it. Here.
I'd say no back talking. Send him to the principal's office.
So, that, maybe back then that could have maybe worked. But, if Einstein's math was right, I doubt that principal was very happy to have his time wasted. How?
Well, in the olden days, she could have just whipped him or something.
Oh, you're right. So, how did Einstein do this? All of that doesn't matter right now.
I'm just saying, I don't think you can whip kids
when my mom was in high school.
Not technically, because so in this story, Einstein's a very young student.
You could whip them.
So ignore your notes for a minute. Let's see, is there any empty space anywhere?
On the back.
No, you can hit him with a board about gay wine on the butt.
Over here. So, hey, guys, focus. So, let's say that we've been given the task, add up the numbers between 1 and 100. We'll make it easy. We'll make that teacher not very evil. So, we could add 1 plus 2 plus 3 plus 4 plus 5 and start doing that. Or, we could try to make some nice pairs that work well together. What sort of ways could we pair numbers to start getting rid of them where they would end up nice? Megan?
1 and 99.
Why is that nice?
Because they add up to 100.
And then what can you do with that?
And then you can add all the 100s you've made, and it's nicer.
Every time I go up from the bottom side and down from the top side, I get the same sum. So if I ignore 100, the top 100, I have 1 through 99. I'll pick up that other 100 eventually. But I have 1 through 99. These add up to 100. 298 add up to 100. 397 add up to 100. And so on all the way till we get to 4951 with the 50 in between left over. So what Einstein did was to think through, okay, if I have two sets, or if I have a set of numbers that I need to add up, what if I actually think about having 2 of those sets of numbers? I can put one from the lowest value up to the highest value, and I can put the other set from the highest value down to the lowest value. When I do that, I can just say that 2 of those sets is that sum term plus the sum term plus the sum
Brady,
term.
cool to the office, please, Brady.
And what I end up with is however many terms I had. my n amount of terms, I get that sum n times. So we can then just say that one of those sequences, so there's my two sets of numbers, come out to have n of those sums. And I can say one of those sets, instead of being n amount of those sums, will be half n amount of those sums. So here our sum would be 100. Depends on the set of numbers that you're using what your sum would be, but if we were adding up, or you could take that original 100 and the 1 and you could just make your sum 101. And then do 299, 101, 398, 101. So you could really make that sum whatever you want it to be. But really we normally start with the lowest value and the highest value of the set. So this right here is mathematical proof and reasoning of why we do that and how exactly it works. So I would highlight, circle, square something, this explicit formula if you want, because this is the basis of our explicit formulas. I mean, you could do n over 2 times n plus 1.
I feel like it looks nicer if you distribute the n and the half, and then you get n squared plus n over 2.
Yeah, which is another way that we write this. And I think we actually might see that on the back here, or we see that somewhere. Once you do the distribution, we end up with
It just looks nicer.
So let's say we try to write an explicit formula to figure out the 20th term. So we're not finding the sum values here. We just want to know what is the 20th term. So switch your brains back from the summation. What is going on? We have term 1 is 0, term 2 is 3, term 3 is 4, or sorry, 8, term 4 is 15. So I see a change of 3, change of 5, change of 7, change of 9. So we're increasing by an increasing odd value. How do
But
we
you're skipping 1 and starting on 0.
skipping 1, starting at 0? Okay, how do we write this out? So if we were going to say the value of, this is so screwed up. Think about this for a second while I orient. How do I find the value of that term?
Why do you press outside of the little thing and then drag it into
So I go back and forth on how I do it. Sometimes if you just dot in the middle, it'll be okay, but sometimes just dotting in the middle, if that pixel that you actually click on is faulty, it kind of goofs everything up. So if you slide in, it has an easier job of finding where are you, and even if that last point is faulty, it knows right where you were going to. You know what I mean?
Yeah.
So it's like if you were telling somebody like, I'm almost to my house, I'm almost to my house, almost to my house, I'm at the library. No, you were almost at your house.
It doesn't pick that up though. It doesn't pick that you're gonna.
It picks up my drag. Yeah.
No, it doesn't.
Yeah, it does.
It's a
When you start
smart
working on a smart board, come back and show me what you figured out.
And
Now,
how do you
another
Fine, it's a smart board.
another way that we sometimes, has anyone figured out a formula for this yet? So I have term 1, term 2, term 3, term 4, term 5. Think of all the things that we could do with the term value. Now we know that this is not linear. And we know that this, well, I kind of just want to stop it. We know it's not linear. So if I look at changes,
3, 5, 7, 9.
ooh, now what does the change in the change tell me? Ooh, so this tells me it's going to be quadratic. So A sub n Now, if it's quadratic, that's going to be in the form. So now where we are used to using x, we can swap that to an n since my input value. So an squared plus a bn plus a c.
I feel like there's a way to derive it from the base, the formula that we just figured out.
We don't. The one right at the bottom of your last page was for the summation of the sequence, not the value of the term. So we're not trying to find the sum of the sequence, we're trying to find the value of the term. As soon as I tell this to you guys, you're all going to face palm. And I really don't want to tell it to you. I want you to figure it out. It's quadratic. Something's getting squared. Something's happening.
Do we have an example of one like this on the?
This is the top of the last page.
Oh yeah, but I'm trying to find if we have like an example of a formula.
No, not yet.
Is it? Oh, I wonder. I can't find.
So we're just trying to figure out so we identified the first level change is not the same, so not linear. The change in the changes is consistent, so we know it's going to be a quadratic form.
I got it.
So all we know is it's in this form.
I got it before you did.
Harmon, punch him.
I'm smiling.
Slowly there. Hold on. Let's give Mr. Estes a moment to see if he can figure it out. Can you figure out the rule to this sequence? How we can represent it using n for the value of the 20th term we're trying to figure out. So my term number is red. Difference in the terms is blue. Difference in the difference is purple. We so far have determined it's going to be quadratic. What we see is a quadratic change.
I don't know.
You didn't sing.
I'm gonna try that.
N squared minus 1.
It's in the homework.
Are you serious?
Yeah. Second question.
1 squared minus 1 is 0. 2 squared is 4 minus 1. Take 3. 3 squared, 9. Minus 1 is 8. 4 squared, 16. Minus 1 is 15. And we can keep doing this.
Oh, that's easy.
So, when...
I got it.
You said, and we can keep doing
So,
it.
20 squared is 400 minus 1. A sub 20 would be, 399. Apparently my smart board hates me.
Whoa.
Do you compliment it enough?
No.
You know, maybe I don't.
He doesn't
You're a
feel
really
love.
good smart board, and I appreciate how much you help me teach.
You should tell it it's beautiful.
Because it wasn't sincere, Mr. Hudson.
Just pretend
Yeah,
you're white.
It could tell that was
Joke
yours.
pretend you're
It
white.
wasn't genuine, Mr. Hudson. Why is your blue pen and black pen always in the wrong compartment?
Because the blue pen is really needs a replacement tip on it.
Oh.
The tip's all mashed in, and it's kind of too fat when you try to use it as a pen. It's not very precise. Just years of use. This smart board is like, this smart board's like as old as you guys.
14?
I don't know. It's old. I don't know when they got it, but it's old.
And smart.
It's probably 8 years old.
They had
Because it got installed. Might be
You
older.
have color
Might be older than
too?
yours.
They had
Like,
electricity
compared
when
to-
we were
Alright, so
Did they have iPhones?
grab a calculator just to make sure that we're able to do this.
Oh, you need a fancy one.
Yeah, grab a fancy calculator. Ethan, you still have one of mine? Ethan, you still have one of mine?
No, one of yours.
Does somebody have one of the Phoenix graphic calculators?
No.
Okay, we'll make sure at the end that there's one.
Yes.
So,
You're my favorite person. Yes.
guys, can we please stop with the side conversations? It's just getting frustrating. So, Pierre began with a $300 balance on his credit card. Now, here's when the banks are not working with you, they're working for themselves. So, they have a 1.8% interest each month. Now, that is actually not that bad. On his unpaid balance. So, in addition to a $29 penalty for any month he fails to make a minimum penalty or a minimum payment, which really happens, but there's been some controls placed on these companies based off they were doing some like predatory type things where they were out to get you. So, Pierre ignored his credit card bill for 4 consecutive months before he finally decided to pay it off. What did he owe after those 4 months? So he is going to have 1.8% of the balance plus another $29. All of that added on to the original balance. So we have to first tell our calculator, I'm starting with 300. So this seems dumb, but just type in 300, hit enter.
Okay.
Then what we're telling our calculator is we want to make a function. Essentially, we're saying function that relates to a previous answer. This is going to make this recursive. This ANS is essentially, and if you would write this on your paper, please, hopefully I can write this somewhere. That's your A sub n minus 1.
Wait, is that why sometimes in calculators, if you do like 3 times 3, then you get like the answer, and then you do times 3, it says answer times 3, how you can make
it is recursive. It's using the previous value.
That's pretty good.
So that ANS is A sub n minus 1 for us in this case. So, to have 1.8% on top of what was already there, we really need 101.8. It missed that center point.
You should drag, because it like.
You know, somebody told me not to, so I was trying it without doing it.
It was easy to drag, you know. Know that?
Fine, dude. How do you learn these things?
I don't know.
This is just filtered.
Oh, you just back
Well,
no, you just back
Instead of dragon, you should do a little swirl and
No.
So, this
you could just pray. Yeah.
and of course I took my little tablet thing home where I could write on the smartboard with
The
y.
tablet thing.
Those are weird, because you don't have like the.
So this is 101.8% of your previous value plus another 29. So once you type that in, every time you hit enter, and this is the dangerous thing about using the previous answer, it's constantly changing. So this ANS is only 300 for that time we use it. The next time that we use it, it'll be 334.4. The next time we use it, it'll be 369.42. So every time you hit enter, that ANS is changing its value automatically. So hit enter a few times and see what happens.
It's each month, right?
Yeah, each of those is a month. So after 1 month, he owed 334.4. After 2 months, after 3 months, after 4 months, he now owes an extra $141. And that's not even that bad. Like, it is bad, but comparative to normal
Wait,
credit
aren't there like
cards.
some like loan sharks thing that
It
have
was
like
like 70%.
Yeah, it's like a 7% interest. And
Now, this is giving you the monthly percentage. When you look at an actual credit card, actually, come here.
It's annual.
Come here. Just seriously, come here.
Yay.
Yes.
Field trip.
Field trip.
Field trip.
We're going on a trip in the day. Come on, good shit.
I don't want to.
Estimated monthly loan payments based on a 9.9% interest, $25,000 with 7.74 to 15.9 interest. So depending on your credit, depending on a lot of things, your interest rate is 3.9. Now that is a variable, so it's going to change. So that's the lowest probably that it ever goes. So all of these, but those big percentages, like when you see like 15%, that's yearly percent. When you break it down to monthly, it becomes less. Because it says if you had this can go back in, but I just want you to like literally every time, like ask your parents the next time they're gonna shred or throw away one of those credit card things. Look at it to read the fine print, and it's actually kind of fascinating how and like scary fascinating how much they can put into that fine print to screw you over.
It would be too sad looking at our bills. I'd be like,
Well, no, it's the offers. When they, like, almost daily, I'm getting mailed freaking credit card offers, and I wish I could just have them send me the postage that they would pay for that. Because they're spending like 30, 40 cents to send these mailers. I don't want another credit card. Like, I just throw them away. But the banks keep sending them because people are going to do it, and then they pay the interest, and that interest they pay pays to send out all those free credit card things. Traveler?
Isn't that like the same thing for those like GMC car commercials and stuff like that, where it says like 0% APR for 12 months, and then the
Well,
fine print at the
Is
bottom
0.9%.
Yeah.
Even if it's 0.9, they can say 0 as long as in the fine print they say it's actually 0.9%.
Is that why
and then they have like 12% APR after a certain
Yeah.
amount of time.
Yeah, yep.
Is that why it says sometimes like we brought in real customers
Yeah.
and the fine print says these are not real
Yeah.
customers?
Yes.
Like that just seems
Yeah,
like
exactly.
Well, okay, so
We brought in
those
real customers.
situations,
These customers are actors.
yeah, they'll say things like, well, these are actually Ford customers, but they're paid actors. Like they're probably real customers. They're saying they're real customers.
Right.
They probably bought a Ford at some point, or there's some clause
But they're
that
also
makes them
big.
customers.
Because they
But okay,
bought it.
moving on.
I bought a
So,
station.
that-
buy a pen from me.
Hey guys, really, really basic. That's how you create a recursive formula on your calculator. So that recursive formula would be saying that a sub n, the value at n, is 1.018 a sub n minus 1 plus 29. So that's all that it does different. I'm going to reorient again. Megan?
Can you make the font size on the calculator different?
You not to my knowledge. I've been wrong before.
Yeah, but it's made of pixels.
He's
What if
doing
you
the drag
can-
thing.
If you doubled it, width and length, it could work.
You can't make pixels smaller, but you can make.
Did you know that you
What's
can
the
add
point ever?
You know there's a chalkboard.
So it covers like half of the pixels. But
There's two
Dude, chalkboard suck.
not half, not of each pixel. But half of the pixels.
All right. So try this. Let's let's look at the variance. Hey, give me your attention again. What if instead of 300, he started with a balance of 500?
Rip here.
So change this. If he $500 instead. Or well, so we want to do this. Hold on. Do you still have what we had in our calculator in there? The 1.08.
No.
Can you want
ANS.
me to?
No, the problem is that ANS is constantly changing, so you might have to reset it to do 300 and then type it in again. If we use the 300, it was originally asking how long would it take us to reach 1,000. Really, we could just look up here and say, what's the next, what's the next, what's the next? Like, we know we already went 4 months.
Never mind, it won't let me go up.
So retype it. Just start over with 300. So we'll first use the 300. So you
12. Oh, that's fine.
1.018 and this.
We're doing 300.
Well, I'm
So every time you hit enter is a month. So 1 month, 2, 3, 4. Yep. At 18 months, he owes them $1,023. So at 18 months, it's 1023. Now, let's compare. What if his initial balance was 500? So reset this. Type into your calculator 500, enter. Then do 1.018.
It takes 12 months.
Second answer plus the 29. 1, 2, 3, 4, 5, 6, 7.
It's 26, I think.
It's 12.
Yeah, he's right. Well, it's 12 to get right below it.
No, it's so
Oh, it says
now
three,
with a $500 start balance At 12 months, he now owes.
So basically, oh well, never mind. That's kind of self-explanatory.
No, I didn't. I was talking about that right there.
You want to do a crazy comparison? What if we do 12 months but start at $1,000?
Oh god.
What if his credit card let him, like, a lot of beginning credit cards either have a limit of 500 or a limit of 1,000. Like when you first get a credit card. Now my bank called me and tried to give me an increase on my credit line. I said no because I didn't need it. My credit line right now, I have two credit lines. One goes to 8,000, one goes to 5,000. I never am going to need to spend over $13,000 of money that I don't have. That is a bad idea. Don't spend money you don't have.
Do you have a good credit score?
Yes, that's high of a house. So
You were talking about that last year.
we started with $1,000. So redo this, hit 1,000, enter.
It's
1.018. Now we're just gonna do this for 12 times.
It's 16.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
16, 20.
So that at that point he's almost like 0.6%.
At that point, you should just sell it.
Wait, six. You mean 60%?
Wow. No, it's at this point. Oh yeah.
6B.
My bad. Yeah. 60% of his original balance.
How'd you get 32?
Oh, it was
That's
33
what I
round.
33. My calculator didn't round.
Oh, did you change your float? Like it's.
Yeah, I'm floating to 6 places.
Oh.
That's whatever. I just picked this up out of the bin. I don't know.
It said to float to 2.
Yeah, we know how to round. So if you want the calculator to do financial math only, that's when you change your float and you make it go to 2 places. The little, it's on your
That's
notes.
just like
It
cents?
literally is in your notes. You just go hit mode.
Oh, okay, so that's like cents.
So financial math, we only work the 2 decimal places.
Oh, found it.
So-
13 places.
This is where that whole like annual interest rate comes in, and I forget exactly how it's calculated. But again, notice if we owe an extra $600, we now owe 60% more than the original amount that we had. Now that doesn't mean that your interest rate is 60%, because that would be pretty crazy. But that's not a low interest rate, right? And but this is saying his monthly is 1.8. Like, oh, only 1.8%. That's great. No, it's not. But also, he's got a fee. If we did it without the fee,
That'd be good.
so what if his bank offered him, look, we'll give you a new account. Like, he decides this bank sucks. I don't like them. I'm going to go to a different bank. They're like, wait,
Yeah.
we'll give you the same thing, but no penalty when you don't pay.
It'd be 21.
So now let's reset this.
It'd be 21.
Do your $1,000, but now just make it 1.018 times the answer, no penalty, and do that for 12 months. 1, 2,
Got it.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What'd you get?
1238.72.
1238.72.
That's still 250 extra.
That's not great.
I mean, shoot, it's
Yeah,
better.
it's not great, but it's not
His
bad.
interest rate annually about 24%. Because in the year from just interest, he would gain an extra $238 that he owes. So saying he would gain is kind of a dangerous statement. But he gains that debt. Like he's gaining more and more debt. So in the annual rate, it's about 24%. But when they break down your monthly, they're like, it's only a monthly 1.8. They're trying to trick you. Now that doesn't seem bad if you pay it off. If you don't, it sucks. Have I gotten the idea of credit through your head that it is very dangerous and compounds very quickly? Because then, if you did it for another year, let's say it still sits there, I'm defaulting on my loans, and that keeps happening. So now do it 12 more times. Hold on, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
1534.
1534.
So he's
And
almost
that's
better.
if there's no added penalties, which there are. There are added penalties.
Is it the bank's responsibility to let you know of unpaid balances, or is that?
I mean, they send you, like, they'll send you a letter, they'll email you, they'll whatever, but if
Why
you
would
don't
they
pay,
do that?
you don't pay. Eventually, they come and they repo your stuff.
Why would they do that? Because I feel like that's kind of like taking.
I mean, you took money from them. You owe money to them.
No, I know,
They
but
don't owe you anything.
if you don't remind them, then they're making more money
It's not their fault to make
Yeah, but they want their money.
They're not
Like
making
they're
money off of you. They're saying you need to give us the money.
yeah, if you don't pay, they don't make their money. So if you end up going bankrupt or end up like whatever, they don't make their money unless you pay.
So you were saying about the 60% that we got?
Well,
And
but
you
that
were
was
saying
with
how-
penalties.
Yeah, and you were saying how that wasn't the monthly.
Yeah.
I looked at the monthly.
Yeah.
From a starting balance of 100, and in a year it compounded to 41,000,
You have to pay taxes.
which is that the lesson why interest looks
Wait.
so low.
Compounded to 41,000, like using what? That percentage of 60, whatever.
Yeah.
Yeah. Yes, it is not because that was with penalties. That was not just percent change. That was with some constant change in there as well. But
Holy.
if we did operate like that, and when we got to the end, it would be as if, right? Like as if we had had that percent change. Because we had a change of 60% compared to our original. So regardless of what the card charges me, if I'm going to look at my math, I'm paying 60% more than I needed to, which is ridiculous. I'm paying over 1.5 times the item value. Just save your money until you can afford it. All right. Well, talked a lot about this stuff.
I guess we're not having the test before spring break, probably, maybe.
No, 2, 3, 4, 5. We might be able to get to it because this will speed up now.
Yeah,
So, did we get a 15 too?
No.
Okay, I have them in a pile over here.
I got you.
Oh, I have a question.
How else would they?
What did you have to follow?
Or correlated? Or no, what's yeah?
Did you say nerd?
Mr. Hudson, what are your dogs' names?
Timber, Sebastian, Marley, and Nico.
Nico.
Or Nikolai, if you'd like to make him sound fancier than
You
he
wanna know
is.
what my dog's name is?
Earl.
Write it somewhere.
So,
Is he here?
you are training for a 10-kilometer race. You would like to tier your training, so every day you're going to run a little bit more than the day before. Sorry, not day, week. No, there's one for me. I get one too, Brian.
Brian.
Trying not to give me
Trying
any.
to finesse.
All right.
You can do mine too if you want to.
Nah, I'm okay. So every week, you're going to change your training to increase by a fixed amount so that by week 9, you're running 10 kilometers. 10,000 meters. So if you're in,
That takes 2 months.
you can
Yeah, no,
think in your head like meters, like 100 meters out on the track. So if we wanted to change by a fixed amount, same amount every week, so that one week doesn't suck more than the other, how can we figure this out? Well, we have easy mathematical ways to figure this out.
Just do the change divided by how many weeks.
So my what do we want to say? My weekly change.
Yeah. So.
So weekly change. So weekly change literally means change every week. And if we want change every week, we want the change over the weeks, which here we can figure out, well, what is the change that we need to accomplish? 6 kilometers. How long do we have to accomplish this? How many weeks do we change?
8.
8.
My
Because
phone.
9 minus
I
1.
included the first week.
This reduces to 3/4, or we can say change by 0.75 kilometers per week. I know. I can't even go back and try to fix it because I won't be able to line up.
What?
It looks like RM
Oh yeah.
because my K is my smart board.
Oh, that's what I thought.
I'm fine with your K, just the smart board.
I don't know, the case pretty weird.
This looks like a capital R. as opposed to a lowercase k. My apologies.
I
Just
prefer
because
that.
you're a good teacher, just fix,
No, that
fix your case.
K is fine.
His,
But technically, it should have been an uppercase K anyways, because kilometers would have the uppercase. Any question on how we did that? Take the total change that you know divided by the amount of time we have, and we can figure out that that is the amount we would need per week.
I like that lowercase k more because other people do it. It just looks like how do you tell the difference between that and capital K?
Oh yeah, they just like make it smaller.
Yeah.
So, the explicit definition for an arithmetic sequence. What's nice about arithmetic sequences is arithmetic tells me we're adding or subtracting the same amount every time. It's consistent. So if we know that we have A, then A plus something, then A plus 2 of that something, then A plus 3 of that something is my consistent change. Here, D for difference. So in this sequence, we see that our consistent change is 3. In this sequence, is it arithmetic? Calvin?
No.
How do we know?
Because it goes 3 and then 5 and then 7 and then 9.
Or changing the changes.
Doesn't matter.
It's
Not arithmetic,
Is this all this is?
pretty much.
Oh my
Yeah, that's why I said
God.
we should still be able to get to our test this week.
Oh my god.
So, Straveler, thank you for volunteering. Is this sequence arithmetic? No. Could you define it? Do you know what it is? This one's pretty easy to define. Yeah, but geometric how?
It goes up by 2, then times 2.
Yeah, so we would say that our value of term at n is 2 times
I was just
a sub n minus 1,
or 2 to the n.
where, yeah, or 2 to the n,
Where a1 is 2.
where a1 is 2.
Or 2 or just 2 to the n.
Because we started 2, we can also write it. So, when we go to analyze arithmetic sequences, we know that we don't always start at a nice, easy value where this sort of thing will work. I could write it as the common difference times how many times we do it, or times the previous value, because that's geometric. This works out because it's geometric. In arithmetic, let's say we start at 6, and the common difference is 5. So we have 6, 11, so on, so on. And we need to figure out the 100th term. Well, I know that that change of 5 happens how many times to get to the 100th term? Happens 99 times. So really, I'm going to take the number of the term, subtract 1. So we're doing 100 minus 1 because the change happens 99 times. I'm going to take my start value of 6 and then times that common difference,
what's in the parentheses?
99.
n minus 1.
100 minus 1.
Oh, that's 99. Yeah, so how many times do we change? Well, to get to the 100th term, we changed terms 99 times. So we could just do 500 minus 5, because we know that's how we could get 5 times 99. So that's 495 plus 6, which gives me 501 for my 100th term. If we are given the first term and the fourth term, and that's all we know, how could we figure out the second and the third? Caleb, we haven't chatted yet today. What do you think?
Sorry? I was saying.
How do you find the second and the third term?
Well, if it's an arithmetic sequence, you know that what happens to the 100 to get to the second one will also happen to get to the third one, and then from there So you know the difference between 100 and 82 is like 18, and it changed the total.
Oh my god.
Hey. So it
Okay,
changed-
keep talking.
So it changed the total 3 times. So you know that 18 divided by 3 is 6. So you know it's just subtracting the 6.
So take the amount of change you
It
know,
should make work.
like quantity, the amount of times that it happened, and divide them together. So Caleb is saying what's happening here is a total change of 18 over the span of 3 changes, and we must have a change of -6. That thing is dancing the fine line of being too distracting for you to be able to handle it. I know. But also what I see is you are less engaged than normal. You are not writing as much as you need to be. So try the guide. Find the 46th term in that sequence.
Wait, is 3 the start point?
Yes.
Okay.
Yeah, when we don't have any ... before it, we know that that's
This
the start
seems to me
point.
like 3 seems like an odd start point.
You're right, it is odd.
Oh, okay. That was just weird.
Wow. I get it.
My bad.
Can you have an arithmetic? It probably would be a sequence. What would it be if it extended infinitely both ways?
Oh, the problem is there's no start point. So that's the issue with infinity. We have to have a reference.
Well, it goes to infinity one way.
Right. But we have a reference. We have a start. So you can have a start and no end. And you can have an end but no start, like if you went the opposite direction. Well, and then you really just have a start with no end going the other way, but you need to have a reference point to be able to like explicitly talk about it. You could probably write some rule where like an absolute value type thing, where I'm going to do this both directions, and then it would infinitely extend either way. I don't know. I should have been using cards. Who haven't I talked with? Lynn, if I'm going to go to the 46th term, how many times did I change terms? Oh, so you're saying from here, from the very beginning, how many times would I change terms? Close. To get from term 1 to term 2, how many changes is that? 1. So it's always 1 change less than the term number. So this is going to be 46 minus 1, which will be 45. Rio, what's my common difference here? 2. So that common difference will happen 45 times. 45 times 2 is 90 plus 3. And we get 93 for where n is 46. Sorry, I should have put a sub 46. So this is a sub 46.
Wait, so 93 is right?
I thought the first
93 is the value of a sub 46. Yep.
I didn't even have to do that. I just
Did you use the 7 as your start point?
yeah, and then I just did that times 2 plus 7.
Yep.
So why are we doing this? If that's hard.
So this isn't hard. So you didn't actually use your first term. That's the thing. When we do this formula, we're using the first term because we maybe only know the first and second. So you used your 7 as if it was your first term. So then you thought of it as having less changes because you took away 2 of the changes that we had already had. So when you said that we had 43 changes, if we start at 7, then we only will have 43 more changes to this. So you just went ahead and compensated for a different start point, which you're allowed to start wherever you want, but then that adjusts like the term number, right? Because if you start on term 3, then that adjusts everything. Oh, we're way out of time. I'm sorry, guys. You need to go to Spanish.
No, it's okay.
Really?
She's not.
We're